So welcome to the penultimate lesson on Unit 3, which is graphs and end behavior. So a lot of this stuff we talked about asymptotes before. We talked about what an even graph looks like, right? They're both going to be, the end behavior is both going to be facing either up or down. It's going to be facing in the same direction. If the leading coefficient is positive, it's going to be facing up. And if the leading coefficient is negative, it's going to be facing down. We talked about odd functions like x to the third, x to the fifth, x to the seventh. They're all going to have generally the same shape, which if the leading coefficient is positive, the right is going to be facing up and the left is going to be facing down. So they're facing opposite directions. And we talked about notation. And then we talked about if the leading coefficient is negative, it looks like a disco dancer going the other way. Okay. So today what we're going to be doing is just going through and sketching. So sketching the graph, sketching and graphing are two different things, but if it says sketch the graph, we want to try to be as exact as possible. So step one, press y equals on your graphing calculator, which I already did, and I plugged in the function. So 2x squared plus 3x minus 5, and then we want to go ahead and hit graph. So, yep, we get something that looks like this. And so what we want to do is we want to find out what the points are so we can graph it onto our actual graph that we have. So 0, -5, right? -1, -2, -3, -4, -5. So 0, -5, I'm going to go ahead and put a dot right there. And then I'm going to look at what the next one is. So 1, 0. Okay, so that is a root. We'll talk about what that means in a little bit. 2, 9. So the top one is 10, so 9 is going to be one below it. And then if I go to the negative sides, I have -1, -6, so -1, -6. And if I keep going, whenever it feels like coming up, yeah, keep going, right? You're just going to go ahead and graph these. So -2, -3, you kind of get the point. And then -3, 4. And so -3, come back, -3, and 1, 2, 3, 4. Okay, so what we want to do next is we want to graph, right? So we're sketching the graph, so we're trying to get this as close to what it looks like as possible. That last one was a little bit off, so let me just change that real quick. So what we're doing now is we're looking for the roots, and the roots again are where the graph crosses the x-axis. So I found one already, right? 1, 0. So x equals 1 is going to be my root, and basically what I'm looking for is where are my y's 0? So that's one of them. So to find the other one, because it's not as obvious, I'm going to go here to y2, and I'm going to put in 0, and then I'm going to hit second trace, and I want to see where those two graphs intersect. So first, second, I already know the second one, so I'm going to go over to the left to where they cross, enter, 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 and I get 2.5. So x equals 2.5 is my other point. So I have a 2.5 and I have 1.0, 0, and then what is the y-intercept, right? That's where it crosses the y-axis, which we already know is 0, -5. It's the first point that we graphed, and again, if I'm not sure, I can go back to my table. So 0, -5 is my y-intercept. What is happening to the far left of the graph and to the far right, right? The far left of the graph is going towards positive infinity, and the far right of my graph is also going to positive infinity. So it says complete this. Y goes to whatever as x goes to the left. So y goes up to positive infinity, and as x goes to the right, y also goes up, right? So the end behavior is going to be the same. And you're going to do something very similar for this one right here, right? So we'll talk about this in a second. Okay, so this is supposed to say, let me just go ahead and just talk about this real quick. This is supposed to say log base 3 of x. So I'm just going to show you how to do this on the calculator, right? So you hit math, go hit up, so go down to log base, and then you're going to go put in the 3 at the bottom, and then put the X right here, and then you're going to hit graph. And so you're going to see something that looks like this. It says, what is the x-intercept, right? So I'm going to do what I did before. So I still have my, under my y2, I still have my 0. So I'm going to hit second trace. Option number 5 is intersection. And I'm going to move over to the right to where it is, hit enter, 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 and it says 1. So the x-intercept is going to be 1, 0. And then now I'm looking for that point 9. So the easiest thing to do here is to go to the table by hitting second graph and go over to the number 9. So you could either scroll down or go to the table set and put 9. So across from 9 is 2. So these are things that we can graph, right? 1, 0, we're going to graph that, and 9, 2, we're going to go ahead and graph that, and then we're going to see what exactly is happening here, okay? So if I go to my graph here, I'm looking for my domain. So if I take a look at what's happening here, the graph is getting very, very close to the y-axis. So it's going to go something like this, and it's getting very, very close to the y-axis, but it will never cross it. So what you need to do is say that the domain is from 0, right, to the right. So how do you say that? You could say from 0 to infinity is going to be the domain, and it doesn't ever touch infinity, so it's going to be parentheses, and at 0 it doesn't touch it either, so it's also going to be parentheses. Another way to say it is x is greater than 0 is going to be for the domain. And now let's talk about the asymptote. So this is very similar to what we talked about up here about asymptotes. So if you take a look, it says, right, if the graph is approaching, let me get to this point right here, right? If the graph is approaching the y-axis, there's an asymptote. And so an asymptote for the general log function will always be x equals 0. And so the x equals 0 line is the y-axis, and you learned that in geometry. So the asymptote is x equals 0, which again is the y-axis, because right here at the y-axis is where x is equal to 0. Extend the graph down even though the calculator does not, right? So you want to put arrows at the end of it, so we did that. So state the domain, we did that part, and state the equation of the asymptote. X equals 0 is going to be our equation of the asymptote. All right, perfect. I'm going to ask you to check for understanding and then do a couple of problems. Good job.